Hello everyone, this is Dr. B. Welcome to Making WASSCE Easy, an initiative of 3B Global Tutors. Today we'll talk about modular arithmetic in lecture 2. Um, so let's look at modular arithmetic. When we talk about modular arithmetic, we really are referring to repeated digits or repeated numbers. Okay. Um, Another way we refer to them is clock arithmetic. Okay, clock arithmetic. Why clock arithmetic? Because we simply repeat numbers, such like when we read off of the clock. So for example, there are different modes. Okay, you can have mode 6 and mode 12. One quick example is mode 12. Let's look at mode 12 because we're familiar with the clock system in mode 12. Bear with me, instead of writing 12 here, we'll start with a 0. Okay, there we go. 6, we have 3, and then we have 9. So we're all familiar with this 1, 2, and then we go that way. So one thing that you would see in mode 12 is that it goes from 1, 2, 3, and then it goes to 11, and then rather than 12 here, I would write 0. And these are all the numbers you need, because this would repeat itself. Okay, it repeats itself. So an example is what would 13 then be in mode 12? We would say 13 is congruent to 1 in mode 12. Okay, so how did we get 1? Okay, well, we know that it goes from 1, 2, 3, 11, right? We have 12 and we have 13, but in our mode 12 we would have 11, then we would have 0 and back to 1. Okay, and so this is what we refer to as 13 congruent to 1 in mode 12. Let's look at another example. Oopsie, excuse me. Let's look at another example in, say, mode 6. All right, so in mode 6, so our numbering system goes from 1 to all the way to 5 and then 0. Okay, so these are all the numbers that we need because it's going to repeat itself. So what does 8 represent in mode 6? So the way to do that again is to go ahead and say, okay, 1, 2, 3, 6, 7, and 8. Okay, that's what we're interested in. So we will start with 1, goes to 2, all right, 3. So rather than we having 6, we would have 0, and this is 1 and 2. So y has to be equals to 2. Okay, so it's fairly straightforward. I've been mentioning a word called congruent. Okay, and let's look at the principle of congruent. Earlier on I wrote 13 is congruent to 1 in mode 12. Okay, so this sign right here is what we refer to as congruent. Let's look at what essentially it means. So we can say in general. Okay, in general, two integers, say a and b, all right, are congruent in modulus n when a minus b is a multiple. Okay, multiple of, oopsie, this is multiple of n. Okay, in other words, we can say a is congruent to b mod n if and only if we have say a minus b divided by n is doable, and you will get some kind of integer. Okay, So here integer we mean 1, 2, 3, and so on. All right, so simply that's all we have to do. Now let's look at some examples, some kind of examples, exam questions. How about that? Let's call them exam questions that we would see in WASSCE. Okay, what kind of questions would we get? For example, I would do 2 examples and we would wrap it up. Let's look at let's look at 5x is equals to 7, mode 8. And so the question is, well, what is x? Okay, actually let me change the screen here. Let me bring in a fresh screen and we will continue. So what is x? Okay, so again 5x equals to 7, mode 8. Fortunately, we can't just divide x and say, okay, well, that is, I mean, divide by 5 on both sides and that's x. No, we have to study what 7 mode 8 looks like. Okay, we have to study that. If we look at 7, we would see that 7 is congruent to 15 mode 8. Okay, we would see that. Why are we interested in 15? Because 15 then becomes a multiple of 5. All right, we can see that if we add 8 to 7 we will get 15, and that's a multiple. All right, if we subtract it from 7 we see it's a multiple of 8. All right, so another way to do this is to say we check. All right, so we check quickly. We get 7 minus 15 divided by 8 and we get minus 1, and that passes. All right, that gives us an integer that we're interested in. So if that's the case, then we can replace 7 by that. So we get 5x is equals to 15 mod 8. Okay, and so finally we can divide and we see that x must be 3 mod 8. Okay, and that's how you solve that in your exam. Let's look at another question and then we would wrap up for today. This question says 6 is equals to y mode 4. Okay, so a neat trick is to apply the rule that we have used earlier on where we said a congruent b mode n. All right, and so a minus b divided by n must be, an integer. So in this case we would see that 6 minus y divided by 4 must equals to 1, 2, 3, and so on. And so if we take the first letter and we solve for that, if we say 6 minus y is equals to 4, if we take the first number and we solve for that, we will get here y is equals to 2. All right, is that right? Yes, y is equals to 2. If we do the next one, we will get y is equals to minus 2. If we do the next one, we see that y is equals to minus 6. All right, so we can represent our answer in form of a set. You can say y therefore is equals to 2 minus 2 minus 6 and so on. That's what y needs to be. Or we can just give a formula and say y must be 2 plus, we notice that 4 is the difference here, so it would be 2 plus minus 4n. You can rewrite it and say 2 minus 4n. Okay, where n starts from 0, 1, 2, 3, and so on. Okay, so this will be your final answer. All right, so there you have it. Visit our website 3bgtutors.com, or leave a comment and mention some other ideas on topics you want to see. Thank you.